You must have heard about balancing equations, balancing chemical equations many times. So what is this balancing chemical equations? So if we take an example of combustion of methane, methane reacts with oxygen to produce carbon dioxide and water. So when you look at the reaction, you see that there are 4 hydrogen atoms here. There's only 2 hydrogen atoms here. Only 2 hydrogen atoms, right? There is 2 oxygen atoms on the reactant side, but there is 2 plus 1 oxygen atom on the product side. So what happened to the 2 hydrogens? What happened? Where did this 1 extra oxygen come from? Those are the questions that we will answer by balancing equation. So atoms will not be created or destroyed. The atoms or molecule for that matter, or matter for that matter, atoms, for now let's just say atoms, not created nor destroyed during chemical reaction. Okay, so they go from one form to another, which is what we said in the last video. We said there will be rearrangement of atoms. Bonds will be broken and there will be rearrangement of atoms. So once we want to find out where those two hydrogens have gone and where that 1 extra oxygen has come from in the previous reaction. So when they're not created or not destroyed, how does this work? How does this difference in the numbers work? We have to understand that whatever have been, how many ever atoms were used or how many ever atoms reacted, those many atoms will also be produced. So atoms will not be created or destroyed. So CH4, I'm going to omit the states for now, plus oxygen yields CO2 plus water. So we want to make sure, because atoms are not created or destroyed, we want to make sure we have the same number of atoms of an element on both the reactant and product side. So here we have 1 carbon atom on the reactant side, 1 carbon atom on the product side, 4 hydrogen atoms on the reactant side and 2 hydrogen atoms on the product side, 2 oxygen atoms on the reactant side and 3 oxygen atoms on the product side. So what do? We want to make sure we have 4 hydrogens on the reactant side as well. So we make it 2 water molecules. Remember, we can't change the water molecule. We have to keep the water molecule same. We can only change the number of waters. So we make this 2. Why are we making this 2? We're making this 2 because 2 multiplied by 2. Okay, so there are 2 water molecules. So if we write it, instead of 2 water molecules, if we write it as 1 water molecule plus 1 water molecules, total it will give you 4 hydrogen. So instead of writing H2O plus H2O, we write it as 2H2O. So now what happens? 2 multiplied by 2, so there's 2 hydrogen atoms in 1 water molecule, so there are 2 water molecules. So totally now there are 4 hydrogen atoms. And what did that do to the oxygen? Now we have 2 oxygen atoms plus 2 oxygen atoms. So now there are 4 oxygen atoms, right? So we evened out the hydrogen. So there's 4 here and 4 here. That's good. one carbon and one carbon. We have 2 oxygens on the reactant side and 4 oxygen atoms on the product side. So we want to now increase the oxygens on the reactant side. So we make it 2 oxygen molecules. So now we have 4 oxygen atoms on the reactant side as well. And this is how we balance a chemical reaction.